Hello, and welcome to the next in a series of lessons I'm doing on computer networking, and this is going to be a lesson on computer networking protocols. So if we have a look at what we're going to be learning here, well, we're really going to be learning what a protocol is and why we need them. And we're going to be studying some of the key networking protocols that we use and that you need to be able to describe at this level. So what is a protocol? Well, the idea here is that computers and software are made by lots of different competing companies. These are often heated business rivals with each other. They're not really wanting to help each other or work together, but computers and software need to be able to talk to each other on a network. When you're sending and receiving information on the internet, for example, you don't need to worry about, are you using a Dell PC or an HP PC? Is the receiver using an Apple Macintosh computer? Are they using a smartphone? Is it by Samsung? Is it by Google? You just want the computers to be able to talk to each other. You want the software to be able to send and receive information across the network. To do this, we need to agree to protocols and standards. So a protocol is just a set of rules governing how a particular process is carried out. Now that might be in any walk of life, any type of business, you're going to have protocols. Just the set of rules you follow to make sure everything is done successfully. When we talk about computer networking, a protocol just defines the rules for data transmission. So how data is sent and received across the network. A standard is a protocol that people agree to follow. Anybody can come up with a protocol, anybody can come up with a set of rules for data transmission, but if nobody agrees to follow it, it doesn't become a standard. And really, we want standards, we want everybody to agree what protocols they're going to use and when, and that way everybody can talk to each other and information can get transferred around the world. So as long as devices are following the same set of rules, then they can successfully communicate and transfer data. A network protocol will include a lot of details, which may include how to set up the connection. Sometimes refer to this as a handshake. How to start and end a message. How to deal with corrupt or missing data. How to format the data being sent. Networking is complicated. We often use a combination of different protocols, each one with a different function. So there's a protocol for sending and receiving web pages. There's a protocol for addressing data across a network. There are protocols for all kinds of things. And again, these are just sets of rules that are implemented in software, and these can all work together to make sure the data gets from one point to another and back again. So really, the main protocol we need to think about is TCP/IP, the Transport Control Protocol and the Internet Protocol. This is the backbone of the Internet. TCP/IP is what's actually getting your packets of data from one computer to the other side of the world and back again. TCP stands for Transport Control Protocol. And when sending data, TCP divides the data into packets. You don't just want a long stream of ones and zeros. That's going to be difficult to transmit. It's going to tie up the network. It's not really good. What we want to be able to do is just break it into packets of the same size and send them all individually. They can all take different paths and be reassembled at the other end. It adds a sequence number to these packets so they can be put back together again. So we've got 1, 2, 3, 4, etc. When they all arrive at the other end, they can all be put back together again in the right order. It adds error correction information, so that when each packet is received, the receiving computer can do a little test, make sure the data hasn't been corrupted. If it has been, it can ask for it to be resent. So when receiving data, So it's on the other, it's been sent, the other computer's received it. When it gets the data, it has to examine the packets for error, make sure nothing's got corrupted on the way. It needs to be able to fix error and look for missing packets. If it finds any, it needs to ask for these packets to be resent. So if the data can't be fixed, the packet needs to be resent. If a packet is missing, it needs to be resent. It then uses the sequence number to reassemble the message in the correct order. So if you look here at this little diagram, we can see the message, which again is just all ones and zeros, a big long string of them. And we're going to break it up into little chunks, and these can all be sent along through networks. They can all take different paths, as long as they all get to the right destination at the end. So once TCP's done its job, we need the Internet Protocol. So once the data has been broken down into packets, it's then the next protocol's job to actually address the information to make sure it gets to the right place. So when you send data on the network across the internet, it passes through many computer networks on the way to the destination computer. You don't have a direct connection to Amazon or Facebook or YouTube. You've got lots of networks linked together to form the internet. All your data gets sent between lots of different networks on its way to its destination and back again. The IP layer is responsible for addressing the packets of data. It's just like when we have an envelope. We need to write down the address that we're sending it to, and then maybe we also want to write down the address that we are, and that way it can get sent to the right place, and then they know who we are, and they can send the information back. An IP is really just like addressing envelopes of data to make sure they've got the destination address and the source address. When sending data, the Internet Protocol adds the destination address to each packet, adds the address of the source location to indicate where it comes from, and at the other end, when receiving data, it accepts the data packets that have its own address attached. So when it comes to the router, it examines the packet of data and says, okay, is it for this network? Yes, we can keep it. If not, we'll send it on to where it needs to go. So it ignores any packets that have a different address, sends them on to the next leg of their journey. So we've already had a look at the top layer, which is TCP. Once TCP is finished, the IP layer adds extra header information to each packet. So we call this extra information added a header. And again, that's just some ones and zeros that include the destination address and the source address. At the other end, when the data is put back together again, the IP layer will strip away these headers, send it up for TCP, and then TCP will put all the packets into the right order, get the message together, and send it to whatever application software needs the data. So IP is why every computer online has what is known as an IP address. So you can see an example down here. So if you want to communicate on the internet, you need an IP address. Every computer has got one. You'll get one as soon as you're online, and that allows people to send you data. And your computer needs to know the IP address of all the other computers in the internet so it can send them data. And the process by which a computer goes from the URL, something like www.facebook.com or www.youtube.com, to this sort of numerical data that the computer needs is a process called DNS, and we'll look at that in a future video. But right now, you just need to know that every computer sending and receiving information on the internet needs this address so it can be located. So for example, www.facebook.com, when I did this video, could be 31.13.90.2. So this was one of the IP addresses associated with facebook.com. And this is what the computer uses to actually send it the data. The computer doesn't really care about facebook.com. That's just a nice, easy way for us to remember it. But the computer is really interested in the numbers. So for most of the history of the internet, we've been using IP version 4, Internet Protocol v4. And this provides a maximum amount of 4 billion different addresses. The exact number is here, but it's about 4 billion. Now, is this enough for every device on the internet? If you think about all the devices you have, all your laptops, all your desktops, all your smartphones, all your tablets, all your different connected internet devices, and multiply that by the billions of people worldwide, you can see that's not really enough. And by 2011, we actually started to run out of IPv4 addresses. So we're looking at a situation where there would be so many people and so many devices online that we couldn't actually give out any more addresses. There's a video here that I will link to in the description below. It's by Numberphile. It's another YouTube channel, but they go through it in quite a bit of detail. It's quite a nice little video. So now we have IP version 6. We skipped IP version 5. IP version 6 has a lot more addresses. It's got 340 trillion different addresses. So even if we expand across the solar system, we're still going to be able to use this for many, many years to come. And an IP version 6 address is hexadecimal, and we've got this kind of nice alphanumeric string here. Looks a little bit different from the older IP4, but gives us a lot more combinations. We use both IP version 4 and IP version 6 today. There's a lot of older equipment out there that still only supports IP version 4, but increasingly technology has been upgraded to IP version 6, and by using a combination of these, we're still able to add new people and new devices to the web, give them addresses so they can send and receive information. So IP addresses can be either static or dynamic. A static IP address is assigned permanently by an administrator, but this ties up addresses even when the device is not in use. So a static IP address would be something like a business would have, like Facebook or a big corporation. That means their IP address doesn't change. Every time they're online, they get to use the same IP address. But most of us, personal home users, are going to use static addresses. So to conserve IP addresses, these are often assigned dynamically. That means whenever you log in, the company that's providing you access to the internet, your internet service provider, will actually send your computer your IP address. When you log off, that IP address will then be reused for somebody else. When you log on again, you'll usually be given a different one. And that way, a small number of addresses can be split between a large number of people. This idea about getting a new IP address every time you log in is called DHCP, or Dynamic Host Configuration Protocol. So we use IP addressing on wide area networks on the internet, but what about a local network, a local area network, or a LAN? Well, then we're using something called a MAC address, which has nothing to do with Apple computers. So every computer needs a network interface card, or NIC, to connect to a network. So this is an example of an old style network interface card. You'd plug it into your computer. Nowadays, these are usually much smaller. They're built into the motherboard. Every device has them: laptops, desktops, mobile phones, anything that's going to be sending and receiving information on a network. So each card has what we call a MAC address, or media access control. And this is used to route frames of data around a local area network. So when we talk about dividing data into little groups, when we're talking about wide area networks, we usually talk about packets. When we divide this data up and transmit it around a local area network, we call it a frame of data. But the idea is fairly similar. And we use the MAC address to make sure these frames of data get to the right computer on a LAN. So your MAC address is for a local area network, and your IP address is for wide area networks such as the internet. But of course, like all networking, the more you study it, the more complicated you get. If you want to know a little bit more about IP addresses, global IP addresses, local IP addresses, MAC addresses, how they all work together, there's another video on here. I'll put a link down in the description. You can watch that if you want a little bit more information. All right, let's keep going. We've got HTTP, the Hypertext Transfer Protocol. We should all know this. This is the protocol that underlies the World Wide Web. So remember, TCP/IP is the protocol of the internet. The internet is kind of the infrastructure that information travels across on the internet. The Hypertext Transfer Protocol is the protocol of the web pages, the data that we like to use and send across the internet. So this is how we send and receive web pages. And remember, a web page is just a collection of files, text, images, CSS styles, JavaScript, etc. So HTTP is how your web browser talks to a web server, how the web server talks to your computer. Underneath that, we have TCP/IP. But in terms of your browser and the web server, this is the protocol that they're using. Remember, we use different protocols to do different things, and they all work together. This is a concept we call layering, and we'll study more about that in the next video. Okay, so here we've got the idea behind HTTP. We've got a browser computer here. It sends information to the web server using HTTP. The information gets sent back, and then your web browser can take all that data and render it so that you've got a nice web page or a video or whatever else you're doing with your web browser. So that's software like Chrome, Firefox, Edge, Internet Explorer, Safari. They're all using HTTP. Now, the trouble with HTTP is that it's not secure. It's not encrypted. HTTP is just ones and zeros. People can intercept it. They can understand it. They can see your data. So for a secure connection, we use HTTPS, and that's Hypertext Transfer Protocol Secure. This means the data is encrypted before it's sent out, so nobody can intercept it and read it, unless they've got the key which allows them to read the data. If you want to know a little bit more about this public-private key encryption system, it's covered in the previous video. So again, this is for things like logging into your accounts, checking your bank balance, buying products or services online. Anytime you're using information that needs to be private or secure, for example, financial information, the data needs to be scrambled in such a way that only the intended recipient can decrypt the data and read it. So let's look at a couple of maybe a slightly older technology. This is FTP, File Transfer Protocol. So back in the day, before the World Wide Web and HTTP became widespread, if you wanted to send or receive files across the internet, we used FTP, File Transfer Protocol. And that's what it is. It's for uploading and downloading files on a network. Nowadays, we just use our web browser and HTTP for that. But you still might use FTP if you're involved in web hosting or you have a website. Often we send information to our host using FTP. That's things like the images and the data that we need for our web page. So you might see this if you're into your building web pages or web hosting. But nowadays, most users aren't going to get too close to FTP. Again, it's an older technology. It's been around longer than HTTP. Remember, the internet has been around in different guises for many decades. It was only really in the early 1990s, with the advent of the World Wide Web and HTTP, that we got web pages, and the web pages were what really allowed the internet to take off and got everybody involved. But prior to the early 1990s, we still had the internet, but it was much more difficult to send and receive and view information, and we used technologies like FTP. Another older technology that's been around for a long time, in fact since the early 1970s, is email. It's been around a lot longer than the World Wide Web. There are lots of different protocols that we use for sending and receiving emails. There are three really important ones: SMTP, POP3, and IMAP version 4. Oh, don't have that, so I'll put a little 4 in there. Very good. So let's have a brief overview of how email works. You're sending an email. It goes from your PC to a web server, an email server, email server. The email server then sends it from server to server to server all across the internet, across the cloud, and then your email waits on the receiving email server. And it just waits there until your friend logs in, and then he can check to see if he's got any emails. If he's got them, he can download them to the PC. So that's a kind of slightly old-fashioned way of doing it, but it's a good way of kind of explaining the technology. All right, SMTP, Simple Mail Transfer Protocol. This is used for sending mail, for sending email from your PC to the mail server and from mail server to mail server. It is not used to send it from the final mail server to the destination computer. And that's because SMTP is a push protocol. That means that the sender sends the message and does not care if the receiver is available or not. It doesn't check if the receiving computer is on, it just sends it out there. If the receiving computer is turned off or is having technical difficulties or it's just really busy, that message will be lost forever. So it's only suitable for sending it to a mail server or from mail server to mail server. Computers that we can guarantee are going to be turned on pretty much 24 hours a day, 7 days a week, 365 days a year. Your friend might not have his computer turned on. We can't use SMTP to send it to him because then that message would be lost forever. So it's not suitable for delivering messages on that final leg of the journey, from the final receiving email server to your home or office PC. So for that, we use something like POP3, Post Office Protocol 3. And this is used by home or office client PCs to retrieve emails from a mail server. So you got your message here. It's just waiting nicely on the email server. You can then log in and go, hello, do you have any messages? Yes, you do. You can download them and view them on your computer. So we call it a pull protocol. The receiving computer starts the process by asking the mail server for mail. The mail server just doesn't push it out there. It has to be pulled in by the PC at the far end. Now, POP3 is fairly limited. Again, it's an older technology. You can only have one mailbox. If you download any emails onto your own computer, they're going to be deleted from the server, so you can't retrieve them later or get them from another computer. And it's got a lot of other problems. It's fairly antiquated. You're not going to use it too often. Nowadays, you're much more likely to use something like IMAP4 if you have to use this kind of system. So it's Internet Message Access Protocol, and again, it's a pull protocol. You log in, you check to see if you have any emails, the email is then sent to your computer. It's not just pushed out to you, the receiving computer has to initiate the connection and ask to download them. It's much more advanced than POP3. Mail is stored on the server until it is specifically deleted, so you can retrieve it, have it on your desktop. You could then maybe check it on your phone or on your laptop, and it's still going to be there. You can still check it out and view it on lots of different devices. You can have lots of different mailboxes. It's got a lot more features. All right, so using a kind of old-fashioned email client. Maybe you might use this at your school, or possibly you might use this at work in the future. You want to send a message. You're going to send it to the mail server using SMTP. It then uses SMTP to get all the way across the internet, all the way to the receiving email server. It waits there until somebody logs in using POP3 or IMAP4 to retrieve the email. Nowadays, of course, we don't really often use email clients like Outlook actually downloaded onto our computer. Nowadays, we usually use Webmail. We use Gmail, Outlook, all these kind of software, and we use it through our web browser. So in that case, we're actually sending it initially using HTTP. I'm sending my Gmail email using HTTP. It goes to Google's mail server. At that point, SMTP takes over, sends it across the internet till it gets to the other mail server, where it waits until somebody logs in using HTTP. They can then download that message and view it on their web browser. So you see, if you're using Webmail, you're not using POP3, you're not using IMAP4. That's only when you're using client software on your actual PC. Nowadays, most of the time, we're using Webmail. So we're just using SMTP with HTTP. As I said before, we use a combination of different protocols implemented through software to actually do all this networking task. Ethernet. So this is another technology that you need to know about. I'm sure you can recognize this kind of situation from the picture here. I think we're all familiar with this. Ethernet is a family of protocols responsible for sending and receiving data along network cables. So there's more than one standard. Ethernet works across a range of speeds, which is why we have more than one protocol. There's different versions. The later versions support greater speed. And it's most commonly used for connecting local area networks. I'm sure you've used it at home. You've probably seen it at school or offices. Just a little note, Ethernet is the protocol. We often refer to this here as an Ethernet cable, but really it has a different name. We often talk about things like Cat3 cable, Cat5 cable, and that's the actual physical cable itself. The protocol is Ethernet, and that's what we're sending and receiving across our Cat3 or a Cat5 cable. But just to keep things simple, we often refer to the cable as an Ethernet cable. We often refer to this cable as an Ethernet cable because we're using it to send and receive data using the Ethernet protocol. Ethernet protocol is split into several parts. It has to talk about hardware. It has to specify the performance expected of the cables, the plugs, and the sockets. So this is what we call a very low-level protocol. It's really concerned about how we get those ones and zeros along the actual physical hardware. It has to talk about the data format, describe the format of the data sent and received over the network. How to deal with things like data collisions. So when two devices send data at exactly the same time, what happens to these groups of data? What happens to the frames? Do they get lost? Do they get resent? What's going to happen? Alright guys, that's actually quite a long video. It's probably the longest I've done. Hopefully you've managed to stay awake, or you've been skipping backwards and forwards, taking the information that you need. Briefly, in summary, protocol is a set of rules on how we do something. A network protocol is the protocols and the rules. Sorry, I'm doing this too long. A network protocol is the rules for sending and receiving data across a network. TCP/IP is the basic protocol of the internet. We've been using it since the early 80s, and that's just basically getting all the information backwards and forth correctly and in the right order on the internet. When we're sending and receiving web pages, we use HTTP or HTTPS if you want a secure encrypted connection, and this is operating on top of TCP/IP. If we're transferring files maybe to a web host, we might use FTP, File Transfer Protocol. We use MAC addresses to route data across a local area network. SMTP is used to send email, but not on that final leg of the destination between the receiving email server and the destination PC. We don't use it for that. POP3 and IMAP4 are the email client protocols that we use. And Ethernet is used to set up and send and receive data on a cabled local area network. All right, well, I'm going to take a break now. My voice is about to go out. Any questions, please leave them in the comments and I'll try to get back to you. But good luck and good night.